multiple choice questions on the solution of linear differential equation with constant coefficient. So let's take a recap of the differential equation. So we have considered the second order differential equation over here. So first we will observe the right hand side function. If the right hand side function is 0, we will call it as a homogeneous linear differential equation with constant coefficient, and if it is not is equal to 0, then we will call it as a non-homogeneous linear differential equation. In case of homogeneous linear differential equation, the general solution is written as simply a complementary function, and whereas in case of a non-homogeneous linear differential equation, general solution is calculated as the complementary solution plus particular integral. For more details on a complementary function and the particular integral, the links are given in the description. And now let's explore the MCQs question on these type of problems. The first question is, the general solution of this differential equation is what? So first we need to observe whether this differential equation is homogeneous or a non-homogeneous. So we have on a right hand side function as a 1. So it is a non-homogeneous differential equation. So in case of non-homogeneous differential equation, solution is composed of two things. One is complementary solution and another is a particular integral. And in case of complementary solution, it has a constant. Now, how many constants are there in this case? So we can observe that this is a second order differential equation because the maximum is a d square derivative 2 times of this y. So it means in solution definitely there are two different constants and even there is a particular integral form. From these four options, you can observe that only C option has this type of a form, complementary function that contains a two different constants as well as particular integral is there as a minus 1 by 2. But we are not sure whether this is correct or not. But from here we can conclude that clearly A and B are not the options, because these two options are the complementary solution of the differential equation. They are not the general solution for any non-homogeneous differential equation. Now either option is C or D. So for that we need to calculate this. So let's first calculate its complementary function. So we can directly write the auxiliary in this case, that is m square minus 2 is equal to 0. So m square is equal to 2. So this implies m is equal to plus minus under root 2. So we have two roots and both are real. So in this case, the complementary solution is equal to C1 e raised to power first root, that is positive root 2 into x, plus C2 e raised to power minus root 2 into x. So till now we are getting the same answer, but we need to check whether the particular integral in this case is minus 1 by 2. So for that we can write this as is equal to 1 upon d square minus 2 into 1. So whenever we have 1, we can convert this into the exponential form e raised to power 0x. So in case of exponential, replace d by a, and what is a? Coefficient of x in this case, that is 0. Substitute d by 0. So in this case, the particular integral is 1 upon 0 minus 2 is minus 2. So yes, we are getting the particular integral as minus 1 by 2, and hence C is the correct option. Next question is, the particular integral of this is what? So we just need to calculate the particular integral. So ypx is equal to 1 upon d square plus 1 e raised to power 2x plus 3. So we know that in case of e raised to power ax, we are replacing d by a for finding the particular integral. Now in this case, if you have a confusion, what you can do, you can split this one. So we can write this as e raised to power 2x into e raised to power 3. Now e raised to power 3 is a constant, keep it as it is. So in case of this, replace d by 2. When you replace d by 2, we have 1 upon 5, because d square is 2 square is 4 plus 1 5 e raised to power 2x. Now you can even club this one. So we have plus 3 over here. The particular integral in this case is 1 upon 5 e raised to power 2x plus 3, and hence the answer is D option. Even there is a short trick you can observe from the undetermined coefficient. We know that if we have a right hand side function of the exponential, always a particular integral contain the exponential term as it is, but it has the cos factor, and that cannot be possible in this case. So we can directly discard the option A, B and C, and final answer is D. Next question is, particular integral of this differential equation is what? So we have in the option e raised to power x, we need to determine what is the constant term over here. So what we can do, that we can write particular integral is equal to 1 upon d square plus 2d plus 1 e raised to power x. In this case, d is replaced by a, and a is a coefficient of x, that is 1. Replace d by 1, we have 1 by 4 e raised to power x, and hence we have the option A. Next question is, find the complete solution of the differential equation this. So complete solution means we need to find the general solution. Now observe this differential equation. This differential equation is a homogeneous differential equation. It means we just need to find the complementary solution. So write its auxiliary equation. D square is replaced by m square plus, here d is replaced by m, and this is a 1, and y is replaced by 1 is equal to 0. So we can write this as equal to m plus 1 whole square is equal to 0. So this is m plus 1 into m plus 1 is equal to 0. Roots are minus 1 and minus 1. So roots are repeated. It means this cannot be the answer. Even this cannot be the answer. Even this cannot be the answer. And the last option is there. That is the correct answer. C1 plus C2 into x e raised to power minus x is the complete solution for this differential equation. Next is the solution of the equation this under these condition is what? How to proceed in this type of a question? Whenever we have initial value problem or a boundary value problem, first we will use this one. It says that the value of y at x is equal to 0 is 1. So let's check it where it is getting a 1. So if you take x is equal to 0 in the first case, so e raised to power 0 minus e raised to power 0. So 1 minus 1 is 0, but we need as a 1, so this cannot be the answer. Check for the second one. So if you take x is equal to 0, it is a 5 times of e raised to power 0 is 1 minus 3 times of e raised to power 0 is 1 whole divided by 2. So we are getting 1 in this case. Maybe that can be the option, but still we need to check for the rest one. In the next case, e raised to power 0, 1, so 5 as it is, minus 3 times of e raised to power 0 is 1. So 5 minus 3 is 2. We need it as 1, so this cannot be the answer. For the next case, e raised to power 0, that is 1, minus e raised to power 0, 1. 1 minus 1 divided by 2, that is always is equal to 0. But we need 1, so it means cannot be the answer. So this implies only B option is correct in this case. Next question is, what is the general solution of the differential equation this? So in this case, directly write the auxiliary equation. So it's a second order derivative, m square minus 4 times of m minus 12 is equal to 0. So now suppose you forget how to find the answer for this quadratic equation. What you can do, we can pick the values m from the option. So it says that according to this, the value of m is equal to minus 6 and m2 is equal to minus 2. So check whether minus 6 satisfies this one. So minus 6 square minus 4 into minus 6 minus 12. Is this is equal to 0? This is 36 plus 24 minus 12. This cannot be is equal to 0. It means m is equal to minus 6 cannot be the factor. Hence, we can clearly discard the option A as well as a C because it also contains e raised to power minus 6. Let's check it for the m is equal to minus 2. So when you put m is equal to minus 2, so minus 2 square minus 4 into minus 2 minus 12. So this is a 4. This is minus minus plus 8 minus 12. So this is equal to 0. It means m is equal to minus 2 is one of its factor. If its one factor is minus 2, that should be a part of a solution. But B does not contain m is equal to minus 2. So therefore this is the incorrect option and the last option is the correct one. Now the question is, what is the general solution of this differential equation? So again write the auxiliary equation 9m square minus 12. First order derivative means m plus 4. Do not write m over here. Y is replaced by 1. So find the roots of this auxiliary equation. So this equation can be written as 3m minus 2 whole square is equal to 0. Now, how to write this type of a factor? One, you can directly observe that. Second, you can observe from the option. According to these options, it says that it has a factor e raised to power 2x by 3. And this is only possible when the value of m is equal to 2 by 3. And it means it has a factor m into 3 minus 2 is equal to 0. So even you can check now whether the second factor is also this one or not, you can evaluate. So from here the values of m are 2 by 3 and 2 by 3. Roots are repeated, it means the answer in form of one constant plus second constant into x e raised to power 2 by 3 into x. So this type of a form is available in the option A. Now next is solution of this differential equation. So write its auxiliary equation. This is m square minus 6m plus 18 y is replaced by 1, that is equal to 0. So it has the option in form of cos and sine. So it means there exists a complex root. Let's find the complex root by directly using the formula. So we can write this as is equal to minus b. The value of b is minus 6 plus minus under root b square, that is minus 6 whole square, minus 4 into a. What is a? That is the coefficient of m square 1 into c, that is the 18, divided by 2 into a, that is the 1. Simplify this, minus minus plus 6 plus minus under root 36 minus 72 divided by 2. So this can be further written as 6 plus minus under root minus 36 divided by 2, and hence we have 6 plus minus 6 iota by 2. This is further is equal to 3 plus minus 3 iota. So it has a factor e raised to power 3x, real part, first constant cos of imaginary part as a 3 plus second constant sine of imaginary part into x. So this type of a form is not available in the A, so that is incorrect. In option B, it has e raised to power minus 3x, hence it is incorrect. In option C and D, both the options are correct because either the constant can be positive or a negative. So in this case, C as well as a D are the correct option. So we can also take the negative sign over here or maybe negative of A. Next question is, what is a particular integral of this differential equation? So let's find the particular integral in this case, that is as equal to 1 upon d cube minus d e raised to power x plus e raised to power minus x. So separate this operator form in each term. Now in this case we replace d by 1. So when you replace d by 1, this is a case of failure. And in this case d is replaced by minus 1. So when you replace d by minus 1, so minus 1 cube is minus 1, minus of minus 1, it is again a case of failure. In case of failure, what we need to do, we need to take its derivative. What is its derivative? That is 1 upon 3d square minus 1 into this term, as well as the additional term is x, plus 1 upon, again take its derivative, that is 3d square minus 1 into e raised to power minus x. Now take additional term in this case as a x. So simplify this. So replace d by 1 in the first case. So we have x upon 3 minus 1, that is 2 e raised to power x, plus x upon d is replaced by minus 1 in this case. Minus 1 square is 1. So again x by 2 e raised to power minus x. So final answer in this case is a B option. Next question is, if there are two repeated roots, that is a plus minus iota b, and second is again a plus iota b, then the corresponding complete solution is given by. So again it is for the homogeneous case because there is a no particular integral. So according to this, so we have e raised to power ax, c1 cos of bx plus c2 sin of bx. But in the next term, it should be multiplied by x, hence this is incorrect. For the next case, what is the incorrect over here? This factor, it should be e raised to power ax and should be multiplied by x, hence this is also incorrect. For the next case and D option, what is the difference? So difference in the term of this A and B is over here. So A is a real part? Yes. So it should be with the term of exponential, and B is a complex part, that should be the part of the sine and cos. According to this, C option is correct and D is incorrect. Next question is, what is the solution of this differential equation? So first we will write its auxiliary equation. Auxiliary equation in this case is m square, because it is a second order derivative, plus y is replaced by 1. This is equal to 0. This can be evaluated as m square is equal to minus 1. M is equal to plus minus under root of minus 1, that is plus minus iota. So in this case the solution is equal to c1 cos of x plus c2 sine of x. Because the real part is 0, so we can write e raised to power 0x outside, that is equal to 1. So according to this, the answer is B option. The general solution of this differential equation. So let's write its auxiliary equation. So its auxiliary equation is, this is a third order derivative, so we can write it as a m cube minus twice of second order derivative m square minus 5 times of first order derivative m plus 6 no derivative, simply y, that is replaced by 1, is equal to 0. Now rather than finding the roots, we can use the options. According to these options, C is directly discarded. Why? Because this is a third order differential equation. So definitely it contains the 3 constants. And in this case, we have only 2 constants. So from the option A, it says that the roots are 1, minus 2 and 3. So let's check it whether it satisfies this auxiliary equation or not? So if you put m is equal to 1, what we have? 1 minus 2 minus 5 plus 6. Is this is equal to 0? Yes. So this can be the answer. Now, what about minus 2? When you take minus 2 over here, minus 2 cube is minus 8 minus twice of minus 2 square, that is the 4, minus 5 times of minus 2 plus 6. So this is minus 8 plus 10 plus 6 minus 16 plus 16, it is getting a 0. Yes, that is the solution of this auxiliary equation. What about 3? So if you take m is equal to 3 over here, this is a 27 minus twice of 3 square is 9 minus 5 into 3 is 15 plus 6. So 27 minus 18 minus 15 plus 6 is this is equal to 0. So you can check it. The sum of 27 and 6 is the 33 minus 15 plus 18. That is again 33. So this is equal to 0. So yes, the root of this auxiliary equation is 1 minus 2 and 3, and hence A is the correct option. Now the point is, if you think that if m is equal to 1 satisfies, m is equal to minus 1 does not satisfy, so we can directly write the answer A. No, because there is a none of these options, so we need to check for every value of m whether it satisfies or not. If not, in that case the answer is a D. Solution of the differential equation this. So write its operator form or directly write the auxiliary equation, that is m square minus first order derivative m, no derivative, so we replace y by 1, this is equal to 0. So m square minus m minus 6 is equal to 0. So what are the roots in this case? So even you can check it from the option. From the option we have the value of m is equal to 3 and minus 2. So from here whether 3 satisfies this, 3 square is 9 minus 3 minus 6. So yes, 3 satisfies this. It means one of its solution is 3. So clearly we can discard the option B and C. Now we need to check whether m is equal to minus 2 or 2 is the solution. So when you take minus 2 over here, minus 2 square minus minus 2 minus 6. So this is a 4, minus minus is plus 2 minus 6. So this is again getting a 0. It means minus 2 is the solution of this auxiliary equation, and the corresponding factor of the differential equation is e raised to power minus 2x. And hence the option A is correct. Next question is, what is the particular integral of this differential equation? So we just need to find the particular integral. In this case, the particular integral is evaluated as 1 upon d cube plus 7d into sine of 2x. So in case of sine, we replace d square by minus a square. So what is the a in this case? That is the coefficient of x over here, that is 2. So minus 2 square, that is equal to minus 4. Now we need to create d square over here. So we can write this as 1 upon d square into d plus 7d sine of 2x. So now substitute the value of d square, that is minus 4d plus 7d sine of 2x. So this is equal to 1 upon 3d sine of 2x. So 1 by d stands for the integration. So 1 by 3 integration of sine 2x. So what is the integration of sine? That is the minus cos 2x divided by 2. So answer is minus cos 2x by 6. And that option is not available over here. Hence the answer is the D option. Next question is, what is the particular integral of this differential equation? So we can write particular integral is equal to 1 upon d square minus 1 into 1. So whenever we have a constant term, we can create in form of exponential. This is written as d square minus 1 e raised to power 0x. Now replace d by 0. So when you replace d by 0, so 0 minus 1 e raised to power 0x. So this is equal to 1 upon minus 1 e raised to power 0x is 1. So answer is A option. Next question is, this term is equal to real part of this one, imaginary part of this one, and or this form, or D option. That is none of these. Now the point is what this indicates over here. So it has x raised to power n cos of ax. And if you observe the option, it has a iota form. It means we need to convert this into the exponential form. So how we can write this in the form of exponential? Or we can check it, e raised to power iota theta, that is equal to cos of theta plus iota sine theta. So if I want to evaluate this one, its real part is cos of theta and its imaginary part is sine theta. And in case of this, how we will evaluate that? Means it is a part as a real. So clearly B cannot be the answer. Whatever it is written, and that cannot be the answer because it is written in form of imaginary part. So either A, C or D. What it indicates? What we need to do? So rather than taking a cos AX, we can convert this into the exponential term. So if we have this case 1 by FD x raised to power n e raised to power iota ax. So in this case, we first operate the exponential. So when we operate the exponential, in that case, d is shifted as plus a, that is the coefficient of x. Now what is the coefficient of x in this case? That is the iota a. Now we d shifted in this case as the iota a. So we can write this as 1 upon f of d plus iota a, and then we will operate this operator on x raised to power n. Now when you operate this one, we just need to evaluate the answer for the cos ax. So cos ax is the real part of this form. So it means this answer is also evaluated by using the real part of this expansion. Next question is, what is the particular integral of this differential equation? So for this we need to observe what is a non-homogeneous function, that is the cos hyperbolic x. So we can convert this cos hyperbolic x into the exponential form. Even you can observe from the option, answer is given in form of exponential. So from here we have one formula, that cos of hyperbolic x is equal to e raised to power x plus e raised to power minus x by 2. Whereas sine hyperbolic x is equal to e raised to power x minus e raised to power minus x by 2. So this can be evaluated as particular integral is equal to 1 upon d square minus 3d plus 2. In place of cos hyperbolic x, we can substitute this form e raised to power x plus e raised to power minus x by 2. So we can take 1 by 2 outside because it is a constant. So 1 upon d square minus 3d plus 2 e raised to power x plus 1 upon d square minus 3d plus 2 e raised to power minus x. In this case, d is replaced by 1, and in this case, d is replaced by minus 1. So this is equal to 1 by 2. When you replace d by 1, so 1 minus 3 plus 2. So this is the case of failure. So rather than taking this one, we will take its derivative. its derivative is 2d minus 3 e raised to power x. Now there is additional term, that is x, plus, in this case when we substitute minus 1 over here, so this is minus 1 square minus 3 minus 1 plus 2. So minus 1 is 1 plus 3 plus 2, that is equal to 6. So this is 1 by 6 e raised to power minus x. Now in this case replace d by e. So we have 1 by 2 into x, 1 upon minus 1 e raised to power x plus 1 by 6 e raised to power minus x. So let's find this option. The coefficient of e raised to power x is minus x by 2, that is available in the option D. And the coefficient of e raised to power minus x is 1 by 2 into 1 by 6, that is the 1 by 12. Hence the option in this case is D.